Dear children, it is a continuation of the chapter Surface Areas and Volumes. Now let us continue the exercise 1 of the chapter. The sixth question. What is that sixth question? A medicine capsule is in the shape of a cylinder with two hemispheres stuck to each of its end. The length of entire capsule is 14 millimeter and the diameter of the capsule is 5 millimeter. Find its surface area. Here, see the figure of the capsule. What is the shape of the capsule? It is a cylindrical shaped with two hemispherical stuck to each of its end. Here, at the end of the capsule, there are hemispheres and the middle portion is cylindrical part. Middle portion is in the cylindrical shape and total length of the capsule is given, that is 14 mm. And here the radius of the capsule is also given, that is 5 by 2. Diameter is given 5 mm. The radius becomes 5 by 2. Then the radius of the cylinder is also same, that is also 5 by 2. And the height of the cylinder is, that is nothing but the length of the cylinder. The length of the cylinder is equals to what? Total length minus radius, that is 2 radius that you have to subtract. That is nothing but the diameter. Here 2 times the radius means that is equals to diameter of the given hemispherical portion. Now let us write one by one. First you write solution. Then R equals, for both you take for cylinder and also for hemispherical portion. R equals 5 by 2 for both cylinder and hemisphere. And for cylinder, you take height of the cylinder is nothing but the length of the cylinder. H equals cylindrical height that equals length of the cylindrical portion. So total length minus diameter of the sphere, that is 2r. Total length is 14 mm minus, take 14 minus 5. You can take 2 into r, that is 2 into 5 by 2, nothing but the diameter of the hemispherical portion. Here 14 minus 5 is here 9 mm. Then here you know that the total surface area of the capsule is the sum of the area of the CSA of the cylindrical portion plus 2 into area of hemispherical portion, because here there are 2 hemispheres. So you write TSA of capsule equal CSA of cylindrical portion plus 2 into CSA of hemisphere. Here why you have to take 2 into 2 ends are of the shape hemispherical shape, therefore we have to take the total surface area of capsule is the sum of the CSA of cylindrical portion plus 2 into CSA of the hemisphere. It is a sum of CSA of the cylindrical portion and twice the CSA of the hemisphere. Then you write, what is the formula to find the CSA of the cylinder? That is 2 pi RH plus 2 into CSA of the hemisphere is 2 pi r square. Here both the cylinder and hemispherical portion is having same radius, same diameter. Therefore, here that is r is same for both. That equals, here 2 is there, you can remove that common, and pi is there, also you remove that common, and r is there, r square is there, so you can remove r as a common. In the bracket what is remaining? Here 2 pi r is outside, means in the bracket h is remaining. You write h plus here 2 is outside, here one more 2 is there, so you write 2, and r square is there, r is outside means r you have to write here, r into r square becomes r into r becomes r square. So here 2 pi r is removed as a common, it is outside. In the bracket we will get h plus 2r. In the first term h is remaining, in the second term 2 and r is remaining. Here r square is there, means r is outside, and in the bracket you will get 2r. Now you substitute the values. 2 into, what is the value of pi? Pi is 22 by 7, and r is 5 by 2, and h is 9 mm. So you write 9 plus 2 into 5 by 2. Here also we have to take same r. Then here 2 cancels, and 22 pi ja. 22 into pi is 110 by 7. Then 9 you write 9 only, plus 2 cancels. Here what is remaining? Only pi is remaining. You write pi. Then that equals 110 by 7. The sum of these two, 9 and 5, is 14. Then you write 2 ones are, 2 twos are, you got 110 into 2. 110 into 2 equals 220 mm square. 220 millimeter square. Here, while removing the common outside, you must have care here. Here h and 2r is remaining in the each term of the 2 pi r h and 2 into 2 pi r square. Or otherwise you can take separately. First you get the CSA of the cylindrical portion, then you get the twice the area of the CSA of the hemisphere. After that add the CSA of the cylindrical portion and twice the CSA of the hemisphere. If you want to do that method, you can follow that method. If you want to follow the second method, you can follow that. So let us discuss about that method also. And here also you have to take r equals 5 by 2. You write r equals 5 by 2 for both cylinder and hemisphere, and h equals cylindrical height, that equals 14 minus 5, 9 mm. And also in this case also that you have to write TSA of capsule equals CSA of cylindrical portion plus 2 into CSA of hemisphere. Now CSA of cylinder. Write the formula 2 pi r, that equals 2 into the value of pi is 22 by 7, r is 5 by 2. Then 2 cancels, and this product of 22 and 5 is 110 by 7 mm square you take. CSA of cylinder equals 2 pi RH. What is the formula to find the CSA of cylinder? That is 2 pi RH. Then you write 2. What is the value of pi? Pi is 22 by 7. R is 5 by 2. H is 9 mm. That is the cylindrical portion's length. 9. Then 2 cancels. Then you write 22 5s are 110. 22 5s are 110 into 9. You will get 990. 990 by 7 is there. 7 mm square. Then 2 into CSA of hemisphere. So you write 2 into, what is the formula to find the CSA of hemisphere? That is 2 pi r square. That equals 2 into pi is 22 by 7 and r square is 5 by 2 into 5 by 2. These 2 cancels, and you know that 22 5s are 110 and 11 5s are 55, means 110 into 5 is 550 by 7. Then TSA equals TSA of capsule equal, add these two. That what you are going to get, 990 by 7 plus 550 by 7. Then the LCM is 7 and 990 by 550. 9 plus 5 is 14. 9 5 plus 5 is 14 plus. So you got 1540 and divide 1540 by 7. 7 2s are 14. 1 4. 7 2s are 14. And 0 means here you will get 220 mm square. Here which method is easy, you can follow that. Now the 7th question. A tent is in the shape of a cylinder surmounted by a conical top. If the height and diameter of the cylindrical part are 2.1 m and 4 m respectively, and the slant height of the top is 2.8 m, find the area of the canvas used for making the tent. Also find the cost of the canvas of the tent at the rate of rupees 500 per meter square. Note that the base of the tent will not be covered with canvas. Here see the shape, and here the cylindrical portion is surmounted by the conical top. The tent is in the shape of cylinder surmounted by a conical top. Here cone is surmounted on the cylindrical portion, and height and the diameter of the cylindrical part are, here height of the cylindrical portion is 2.1 meter and the diameter is 4 meter. Slant height of the top is 2.8. Here the slant height is 2.8 m and the diameter means, here diameter of the conical portion and cylindrical portion are same, and it is 2.8, means the radius becomes 2.8 by 2, that equals 1.4. And what is the height of the cylindrical portion? That is 2.1 m. Now here we have to find the CSA of the cone and also CSA of the cylinder, and we have to find the sum of the two area. After that we have to find the cost of the total canvas used with the rate of rupees 500 per meter square. The diameter of the cylindrical portion is 4 meter. Here both cone and cylindrical portion are having the same diameter, that is 4 meter. So the radius is here 4 by 2, that equals 2 you will get. And the height of the cylindrical part is 2.1 m. To find the total surface area of the canvas used, we have to find the total surface area of the tent. And here the upper portion is conical part and the lower portion is cylindrical part. We have to find the curved surface area of both the conical part and cylindrical part, and we have to add the CSA. And here you can get the TSA of the tent in combining form or separately. Now let us take the solution here. Then you write R equals D by 2, that is 4 by 2 equals 2 meter. That is for both conical and cylindrical portion. Conical and cylindrical portion. Then here for cone, L equals 2.8 m, that is the slant height of the conical portion is given, that is 2.8 m. And for cylinder, H equals 2.1 m. 2.1 m. Now you know that TSA of tent is the sum of what? CSA of cylindrical portion or cylinder plus CSA of the cylindrical part plus CSA of conical part. And you know the formula for the CSA of the cylinder, that is 2 pi RH plus CSA of the conical part is pi RL. CSA of the cylindrical part is 2 pi RH and CSA of the conical part is pi RL. For conical part it is pi RL, for cylindrical part it is 2 pi RH. And here we notice that R is same for both, so you can remove common here, or also you can remove common. Here pi is there, remove that pi outside as a common, and R is there, that also you can remove outside as a common. In the bracket, what is remaining here? Pi R is outside, means what is remaining? 2H is remaining. Plus here pi R is outside, what is remaining? L. So you got pi R into 2H plus L. Then you substitute the values of pi R and H and L. Pi is 22 by 7. R is 2 and 2H, 2 into H is 2.1 plus L is 2.8. Then you write 22 by 7 into 2 and 2.1s. You know that 21 2s are 42. 2 1s are 2, 2 2s are 4. So you got here 4.2 plus 2.8. Then add 4.2 and 2.8. You will get 8 plus 2, 10 and 4 plus 3, 7. So you got 22 by 7 into 2. The sum of these two, you got here 7.0, that is nothing but 7. 7 you write. 7 7 cancels. So you got 44 meter square. Then what is the total surface area of the tent or canvas used? So TSA of the tent equal 44 m square. Therefore area of canvas used is 44 m square. Now here we have to find the total cost of the canvas. Here the rate is given rupees, that is rupees 500 per meter square. So total amount or the cost of the canvas, total cost of the canvas, you take total cost of the canvas equal 44 into 500 rupees. Write 0 0 as it is. 5 4s are 20, 2 carry, 5 4s are 20 plus 2 22. How much rupees is it? Is 22,000 rupees. Therefore you write the cost of the canvas of the tent at the rate of rupees 500 per meter square is rupees 22,000. Therefore cost of the canvas is 22,000 rupees. By finding the CSA of the cylindrical part and CSA of the conical part separately, and after adding them, then also you will get the same answer, and follow the method which is easy for you. If you want to follow that also will be done here. So what you have to do for that? Here up to this you have to follow the same step. Write the value of R, write the value of H, L, and write the value of H. That is R equals D by 2, 4 by 2 equals 2 meter, and L equals 2.8 m, and H equals 2.1 m. Then you write this relation. TSA of tent equals CSA of cylindrical part plus CSA of conical part. Now you take CSA of cylindrical part, that equals 2 pi RH equals 2 pi RH, that equals 2 into 22 by 7 into R. R is 2, H is 2.1. Then you know that 7 ones are 7.3s. Then 2 into 22 is 44, and 2 into 0.3 is 0.6. Then 6 4s are 24, and 6 4s are 24 plus 2, 26. You got this area. Next, CSA of conical part. CSA of conical part, that equals pi RL. So you will get 22 by 7 into R is 2 and L is 2.8. 7 ones are 7.4s. Again it is 22 2s are 44 into 0.4. Then it becomes 4 4s are 16. 4 4s are 16 plus 1, 17. You got 17.6 m square. Then add these two, 26.4 plus 17.6. 6 plus 4 is 10. 7 plus 1 8. 8 plus 6 14. So you got 44 m square. Therefore TSA of tent equals 44 m square. Then cost of canvas used. Cost of canvas used equal, same that you have to do, 44 into 500, again 0 0, 5 4s are 20, 5 4s are 20 plus 2, 22, you got 22,000 rupees. Therefore, you write cost of the canvas used. Used equal rupees 22,000. You follow any one of the method, not two. You select the method which is easy for you. Question number 8. From a solid cylinder whose height is 2.4 cm and diameter 1.4 cm, a conical cavity of the same height and same diameter is hollowed out. Find the total surface area of the remaining solid to the nearest cm square. See the figure here. Here is a cylinder. What is the height of the cylinder? That is 2.4 cm. And that is the same height for the cone also. That is conical shaped cavity is done here. Conical cavity of the same height and same diameter is hollowed out. Here we have to find the total surface area of the remaining solid. And you know that here it is a solid means it is having upper and lower bases also. When it is hollowed means the one portion of the cylinder, the upper or lower portion of the base of the cylinder will not be hollowed, but the other base will be removed out here. So here, to have the total surface area of the remaining solid, we have to find the surface area of the cylinder plus surface area of the cone and also plus surface area of the base, area of the base of the cylinder. So let us have the solution here. So what is given here? The diameter is given, that is r equals, you can do d by 2, that equals 1.4 by 2 equals 0.7 cm is the radius of both cylinder and conical part. And height of the cylinder is given, that is also height of the cone. Height of the cylinder is 2.4 cm. To find the surface area of the conical part, slant height is required. And how will you get the slant height? Here L equals question mark. Then you know that L equals square root of h square plus r square, and h and r same for both cylinder and conical part here. Then you write L equals h is 2.4 whole square, r is 0.7 whole square, and 2.4 whole square is 2.4 into 2.4, 4 4s are 16, 4 2s are 8 plus 1, 96, and 24 2s are 48, that is 4 2s are 8 plus 4, you will get 576. You know that 24 square is 576 and 2.4 whole square is 5.76. Then you write 5.76 plus 0.7 whole square. 7 square is 49 and 0.7 square is 0.49. Then find the sum of these two. 4, 9. 9 plus 4, 9 plus 6, 15 and 2. So you got 6.25 here. Got L equals square root of 6.25 and square root of 625 is 25. Then square root of 6.25 is 2.5. As here there are 2 digits after the decimal point, its square root is having 1 digit after the decimal point. Therefore, square root of 6.25 is 2.5. Now you got L also. Then total surface area of the remaining solid equals TSA of remaining solid equals what? It is the sum of the area of the circular base plus curved surface area of the cylinder plus curved surface area of the conical portion, which is removed out here. Then you take CSA of cylinder plus CSA of conical part, cone, plus base area. One base is remaining here. One base is removed out because it becomes hollow in the shape of conical. The hollow part is there and one base will remain. Therefore, we have to add the base area to total surface area of the solid. Then CSA of cylinder. The CSA of cylinder is 2 pi RH plus CSA of cone is pi RL plus here base area is, that is a circular base, so it is pi R square. CSA of cylinder is 2 pi RH. CSA of cone is pi RL. And base area, base is circular in shape, so it is pi R square. Then you write here, if it is possible, try to remove common. You know that pi R is there, here also pi R, you can remove common. So remove that outside, it becomes easy for you, pi R. And what is remaining here? 2 and H. 2H is remaining in the first term. Plus here pi R is outside. What is remaining? L is remaining. Plus here pi R is outside means R is remaining. Pi R into R is R square. Then it equals, now you substitute the values. Pi value is 22 by 7 into R. R is 0.7. 0.7. 2 into H. H is 2.4. 2.4 plus L. L you got 2.5. 2.5 plus R, again you write 0.7. Then you know that 2 7 ones are 7.1s are 22 into 0.1. What is 22 into 0.1? You know that you will get 22 ones are 22, but it is 2.2. So the product of 22 and 0.1 is, you write 2.2 into 2 into 2.4, that is 4 2s are 8, you will get 4.8 plus 2.5 plus 0.7. Then you take the sum of 4.8, 2.5 and 0.7, that is 8 plus 5 is 13, 13 plus 7 is 20, 2 plus 2 4, 4 plus 4 8, that is 2.8 into 8, 2.8 into 2.2 into 8, 2.2 into it, that equals 8 to the 16, 8 to the 16 plus 8 to the 16 plus 1, 17. You got 17.6 cm square, 17.6 cm square, and nearest is, here it is more than 5, so you can take nearest to 18 cm square, that is to the nearest cm square, nearest cm square. Here also you can find the area separately and you can get the sum of all these three. Now the ninth question. A wooden article was made by scooping out a hemisphere from each end of the solid cylinder as shown in the figure. If the height of the cylinder is 10 cm and its base is of radius 3.5 cm, find the total surface area of the article. Here there is a cylinder. Then what is the height of the cylinder? Height of the cylinder is 10 cm. And the radius of the base is given, that is 3.5 cm. And what you have to find out? Find the total surface area of the article. Then you write the solution here. Here the appearance is cylindrical shape, but here you can observe that a scooping out of a hemispherical shape. Here this article is having scooping in the hemispherical shape. Two hemispherical shape is there in the upper portion and lower portion. So the total surface area of this article is the sum of the area of the sum of the curved surface area of the cylinder plus 2 into CSA of the hemispherical portion. Here two hemispherical portions are there, so we have to take 2 into a curved surface area of the hemisphere. Then you take R equals, R is common for all, 3.5, and height of the cylindrical portion, that is height of the cylinder is 10 cm. Then you write the formula for the total surface area of the article, TSA of the article. Right? TSA of the article equals CSA of cylinder plus 2 into 2 CSA of hemisphere. 2 CSA of hemisphere, and CSA of cylinder, that you know, that is 2 pi RH plus CSA of a hemisphere is 2 into CSA of hemisphere is 2 pi r square. 2 into 2 pi r square. If it is possible, try to remove common. 2 you can remove common, and pi also you can remove common, and r also. R is there, r square is there, r can be removed out. And in the bracket here 2 pi r is outside. What will remain? H. Write H, plus here 2 is outside, pi is outside, r is also outside, and what is remaining? 2, and here r square is there. As r is outside and inside the bracket, what you will get? R. You know that r into r is r square you are going to get. Therefore, here 2 pi r is removed as a common, and inside the bracket the two terms are h plus 2r. h and 2r. Now you substitute the values. 2, pi value is 22 by 7. R value is 3.5. And h is 10 plus 2 into r. R is again 3.5. Then you can cancel here 7 on the 7.5. Then 2 to 22 is 44 into 0.5 and 10 plus 2 into 3.5. You know that 35 to the 70. 3.2 the 7.0. Then it is 44 into 5. 44 into 5, you know that 220. 5 4 the 20, 5 4 the 20. So you are going to get 220. But here 0.5 means you will get 22 only. So 44 into 0.5 is 22 into 10 plus 7. 10 plus 7.0 is 17. Then what is the product of 22 and 17? 17 2s are 34. Again 17 2s are 34. 34 plus 3, 37. You got 374 cm square. Then what is the total surface area of the wooden article? That is 374 cm square. Therefore, total surface area of wooden article. Total surface area of wooden article is 374 cm square. So, the exercise 1 of that chapter is completed.